Hello everyone, my name is Timothy Legrand and it is time to revisit an old enemy. So it is this number 105, this question right here on Leetcode. So construct binary tree from preorder and in-order traversal. All right, so I tried this problem a couple days ago and I was completely confused. I was like, I don't quite understand it. And I said, well, I'm going to come back to it in a couple days. I'm going to watch a video to try to understand the concept. So I did that, 3 days ago. Now it's time for me to come back to it today and see, like, okay, well, what observations can I make? I'm going to try to solve the problem again right now. I'm going to see, all right, well, does the idea come to me immediately? If it does, that means that I doubt that's going to be the case. But if I'm able to, that means that I was able to very easily understand the concept that I saw in the video a while ago. That's one idea. The other one is, okay, well, if I'm unable to solve it, I need to go and make observations on what went wrong, where my stumbling blocks are, etc. So let's just try to look at this problem again and see if we're able to make any useful observations and move forward in our Leetcoding. So here we go, number 105. Construct binary tree from preorder and in-order traversal. Okay. So, given two integer arrays, preorder and inorder, where preorder is preorder, inorder is inorder, construct and return the binary tree. So we're given these two lists, okay? And the list indicates the value that each node has based off of its preorder or in-order traversal. So for example, here in this graph, I have, let's go preorder. So I come here, I process it. So that means 3 is the first node to be processed. Okay, 3. Then I go left, and it's 9. Process. I try to go left, but I can't. I already processed it, so I don't do it again. I'm here. Process, which is 20. Process, which is 15. Nope. Nope. Process, which is 7. And that's how we get this. Okay, so that's just letting us know, like, here is the preorder list that we get. Likewise, with the in order, we're going to do the same thing. So we come here and we don't process it yet. We go here, we don't process it yet. We try to go left, we can't. We come back up, now we process it. So that's why we get the 9 there. Then we process it here. Okay, not yet. Process the 15. Process the 20. Process the 7, like that, okay? So that's how we get these. Now, our goal is to actually create the tree, because we're just given lists, two lists of the values of the node in the preorder and in-order traversal. So how do we actually build a tree? Okay, so that was kind of our question. I remember that this is recursive, and I'm going to build. So the preorder always gives the first node, okay? And then I can, see. So this is 3 here. And I notice 3 in the in order, okay? And I also see how this, 9 right there, is all of the 3's left children, okay? And all of this is 3's right children. So I can kind of use that as a way to as a way to do what? Determine who's my left and who's my right, maybe. Okay, so how would I do this? So I have my root, so I need to create a root. So root is equal to, and then tree node. Oops. Tree node, and I'm going to pass in val, which is the first one in the preorder. So preorder, the 0th element, okay? Then I'm going to have left is equal to none and right is equal to none, which is what I want because I don't want either one of them to have a left or a right yet. I'm going to build that. So what is the base case? The base case is if not preorder, return null. None. I don't know if that's correct because look at this example too. It's saying like if I get a -1, I just need to return a -1. So I don't know. Maybe I can do like if preorder of 0 is equal to -1, return -1. But this doesn't feel right. It feels like I'm kind of just like reaching for this. I'm just like, how would I describe that? I'm just filling in a base case to just take care of that one example. But I feel like the base case should be the same for all my cases as I go all the way down. I'm not sure. Okay. But anyways, so we return none if there is no preorder. Okay, so now what I want to do is left is equal to build tree. So I'm calling myself, and I'm going to pass in order. Okay. So now I'm at this, and I want to pass in the next one, right? But how do I know that there is a next one? Okay, so my in order is going to, okay, so I need to check in order. So if length of in order is greater than, oh my goodness, I have no idea, than 1, okay, then I'm able to do my left and my right. Okay. So now when I'm looking left, I want to pass in the next of the preorder of, so the 1th element. And then in order is going to be the 0th element, which is why I checked this. That's why I said if there is a 0th element. But now, why can I do this? Like, why can I do the 1th element? And I think it's, at least the way that I'm conceptualizing it, is that if there exists a in order 0th element, that means that there does exist a oneth preorder. Maybe. My goodness. Okay, this question is like mind-bending. So then we can do what? Root dot left equals left. Okay, root dot right equals right. Oh, we didn't even build the right yet. So what is the right? That's going to be 20 here. So I need preorder of 0, 1, 2. And then this actually needs to be a slice. So I need in order of... Yo, I have no idea what I'm doing. Okay, I have no idea. How do I keep track of my current? Okay, well, we're just going to go to the answers. And we need to figure out, like, why I wasn't able to solve it. So, okay. Is the 0th, okay. Yep. Root, yeah. Index, what is index? Equals in order index dot index. What? Does this give like the... I'm guessing that this index method on a list will search the list and give back the index at which that value occurs. Okay, which is kind of why I was getting a little bit like not doing good right here, is because I was thinking like, okay, well, how do I find where I am relative in the list? Okay, so that's how they're doing it. And notice I just put in one value. So I'm take some notes right now. So first I'm going to say like I was unable to solve this problem by myself. Unable to solve this problem by myself after watching the video 3 days ago. Okay, why? What? There has to be some kind of like misconception that I'm getting. So obviously I just put a 1 right here, but the actual thing is 1 sliced with this index. So this problem, what did I learn from that? This problem requires, I'm given an array, okay? I am given an array, and want to find my root relative in that array. Okay, so I can use that index to find myself. I can use that index to find myself. Okay, but then the other thing that I'm trying to figure out is when I was going through the problem, I was simply looking at the, okay, so let me actually submit this so that I have it in my history. Obviously it's not going to work, but yeah, it doesn't even compile because of that. But anyways, I just wanted to put that in my history. Now I'm going to put this in my history. And I'm also going to make sure that it's correct. Okay. So let's run that. Okay. So I'm going to put a little comment. This is someone else's code. Need to investigate. Okay. So now I'm putting this in my history. Okay, so it works. All right. So what I was doing when I was doing when I was trying to build it, I was just looking at these numbers and like 9 here is that node. And so I was just looking at the picture and building it from the picture. Okay, so I was building it from the picture, but that picture doesn't necessarily abstract out, right? So I was looking at the picture, but that picture does not abstract out. You know, what I think I'm gonna do is instead of really trying to, I'm trying to think, should I just first memorize this solution? Just memorize the solution first off. Then what I do is once I memorize the solution, I try to understand why. So like, why do I get a -1 here? Like, they're only doing one call right there. I did multiple calls, or I did that. Remember what I was saying about it doesn't feel right because the base case should be the base case abstracted out. So why does this have like, does this work even when there's a -1 there? So I need to go in and after I memorize the actual solution, just memorize this solution, then go and try to understand how it works, and then try to move and understand more of the meta of this problem. Okay, so yeah, I think that's the way I'm going to do it because this question is so difficult for me to understand conceptually of like in order. I understand like, okay, well, I can do an in order traversal. I can do a pre-order traversal. Like I understand it, but I guess I don't understand the meaning. I haven't internalized the meaning of how the in order traversal gives me information in conjunction with the pre-order gives me other information, and I can put those two together in some way. Like That is the point of this problem. But I'm having difficulty understanding that. So what I think I'm going to do is just memorize this. Then try to understand, like, okay, well, now that I know the steps, I can figure out why the steps. And then once I figure out why the steps, I can think about the meta analysis of it. So, okay, fine. I'm going to write that down too. I think I will first memorize the actual solution. Then I will understand why each step. In the solution. Then I will try to get, a more holistic understanding and conceptualize what information these traversals actually give. And understand what actual information these traversals give. Okay, I think that's my plan. All right, so let's kind of do this. So the base case is if preorder does not exist. So preorder means the root, right? Because that's where I'm going to get the root. Okay, so if preorder doesn't exist, I just return none. Okay. Oh, look, by the way, look at this. I did return root right here, or the solution does return root here, but in my solution, let's look here. In my solution, I had this, and I was planning to build the tree, but I didn't even think to return root. I need to write that down too, because that definitely is a misconceptualization on my part. I wasn't even thinking to do this. Let's say that I had actually done this part correctly. Okay, let's say that I did the slicing correctly and I had that conception. I also just now realized after looking here, I wasn't even thinking about this. I wouldn't have done this because it didn't even cross my mind. Okay, so here's another problem in my conception that I'm going to write that down too and try to work through, like, okay, well, why did I forget that part? Why did I not know about that part? What does this indicate about my current state of understanding, and how do I fix that problem? Okay, so I see that I need to return root. To return root. I didn't do that in my implementation. In my implementation. Why do I need to return root? Why do I need to return root? And then I'm just going to say this is a point of investigation that I need to do. This is a point of investigation that I need to do. Okay, cool. So, need some more coffee. Okay, so I'm looking at preorder. Okay. Preorder gives me the root. If I don't have a root, I return none. I get the preorder as the value. I create the node. Okay, that I understand. I get the index of my root. Okay, so I get my index of my root. My root is, but I get it in the in order. Okay. Okay. I get it in the in order. Uh-huh. And then from that, I now want to create a left and a right child, which is what I was trying to do initially, right? And I do self dot build tree. Okay, so I need to do the self. Okay, that's fine. Build tree, and then I use my own preorder, okay? But then I slice it from the 1th element to the 1th plus index of the in order. And then in order, I want to start at the start and go all the way to the index, which is going to be this one, 3, right? But not including it, which makes sense because I want all of this and pretend like there's more stuff here, right? Like I want all of that. That's part of my left tree, okay? Now the right is going to be the flip mirror. So I want to start here at this 20, but I want to include all of this. So that means I want like 3 here, and then I want all of this at my index, but not including my index. So I'm not even looking right now. It's going to be index plus 1 because the start is inclusive. So I don't want that index. So index plus 1 all the way to the end of my list. Index plus 1 all the way to my end. Yep, so I got that, okay? So these two make sense. So I don't want to include this one, but I want to recursively build my left and my right. And I understand how that works with here's my left, here's my right subtree. But what I'm failing to kind of understand right now is like, why do I do this? I'm slicing my preorder now. I'm slicing my preorder with index, which is of my in order index, okay? So I'm going to look at this 20 maybe. Okay. So I have this 20. Here's my root. Okay. Now I want to go to my left. So I'm looking at my left. Okay. That's 15 here. So I want to pass in the 1th element to the 2 with element. Oh my goodness. Okay, so I'm going to try to go to Copilot and see if I'm able to get it to explain this to me a little bit better. So let's see, this is my Node.js one. This one, yeah, this is my Leetcode one. Okay. So I don't understand how we are slicing the preorder when passing in to the recursive call. Can you help explain this? This in different ways. All right, let's see what it comes up with. Well, it's thinking. I have my 2 cups again. Here's my coffee, here's my sparkling water. So it's coffee, this one. Much needed, and then some hydration. Okay, so absolutely, this is our classic recursive tree building problem, and the slicing of the preorder can definitely be confusing at first. Let's break it down from multiple angles so it clicks. So I'm given preorder, root left, right, yeah, in order, left, root, right. Yep. The goal is to rebuild the binary tree using these 2 traversal orders. Okay? So, key insight. The first element of preorder is always the root of the current subtree. Right. I'm gonna get this maybe like that, and then here. Okay. So I don't like that because it's still a little bit. Okay, there we go. So the first element of preorder, okay, preorder, the first element is always the root, yeah. In order, everything to the left of that root is the left subtree, and everything to the right is the right subtree. Okay, cool, yeah. Got it. The number of elements in the left subtree from Inorder tells you how many nodes to grab from preorder left subtree. The number of elements in the left subtree, okay, from Inorder the number of elements. So I have Inorder and here. So the number of elements, so there's 1, right? Tells me how many nodes to grab from preorder. From preorder. Oh, okay. Like I need to. I think that this might be what I was kind of very hazily getting to at the very beginning of this when I was doing my problem or my solution. I said, Well, I think what I can do is do this check. I said if in order. And then I said, well, I think that guarantees that there's a value in my pre-order. I think that's what I was trying to kind of allude to. Okay, so there's a connection there between that very fuzzy, hazy idea that I was having. And now it looks like, okay, well, that idea actually is true, kind of. Like there's some line of reasoning that I don't understand yet, but you know, I need to continue to think about that one. Okay. So, okay. From Inorder, so it tells me how many nodes to grab from the pre-order. Okay, fine. I need to expand this a little bit more still. Okay. Okay. So, how many to grab? So I have one here, and so I need to grab one there. And that corresponds to this one. So this is a fixed value. This is fixed. And then starting here at the one, I want to go over how many indices. That's one. So 1 plus 1 is 2. So I want to start at 1 and end at 2 non-inclusive of pre-order. So I want to start at 1 and not at 2 non-inclusive. So I only pass in this array, which is of element 1. Okay. So now with my right subtree, I want to do pre-order, and I want to have one plus index, which is here, all the way to the end. Okay, okay. So I think I see kind of what's going. I don't like. This is so hard for me to actually conceptualize. Right now, again, I'm just in the memorization phase. I'm just trying to figure out, like, get to the point that I can kind of see what's going on enough that I could blindly recreate this, even if I don't have a complete conception and feeling for it. Okay. So, yeah, that makes sense. This is okay. So, pre-order 1 to 1 plus index skips the root at index 0 and takes the next index, okay? So, yeah, I have this, and I just want to skip this element. So that's why I do that 1. And then how many do I grab? Well, it's the number of elements in here, okay? Which right now is just 1, so I just grab that 1. Then on the right, we do something very similar, but I know that I've grabbed one element here, so I need to add all of the rest. So it's where I stopped on the left subtree, right? Because they're either the node, the root, which is at the beginning, or the left subtree, and I know where the left subtree stopped, and so then I just pass everything else in for the right. Okay, so I'm just gonna read this. So think of Preorder as a to-do list. Build this node, then it's left, then it's right. Think of Inorder as a map. Here's where the left and the right subtree are split. Okay, so what I'm gonna do is I'm just gonna come here and delete this. I'm gonna take a sip of water, and then I'm gonna try to do it. Now that I saw the solution a couple seconds ago, I'm gonna try to do the solution myself, see if I'm able to get it from a 10-second memory, right? Then, if I am able to get it, I need to continue to go through it and understand it better. If I'm not able to get it, that again indicates that I need to go back. I didn't memorize it. And then I also need to make sure that I don't just forget about this problem. I need to do it tomorrow. I need to do it the next day, right? So, okay, there's a lot going on right now. So, what was the base case? So if not, and we want the root, right? Which is preorder. So if not preorder, we return none. Okay. Then what I want to do is I want to build I have my preorder, so I can build a root. So root is equal to tree node, and then I'm gonna put in val, which is, and I want to get that value, so root val is equal to preorder, the 0th index, okay, of preorder. Okay. So I pass that into the constructor of the tree node. Okay. Then what I want to do is I need to find out where that value lives within the Inorder, because this is where things are split. So I want to find index is equal to Inorder dot index of root val. So I'm finding the index which it lives at in this Inorder, which Inorder tells me where it splits. I'm going to actually write that down. Inorder tells me where it splits. Okay? So now, okay, what do I want to do? I want to add the left and the right. So this is where I need to do those. Now, from my memory, I don't remember it doing any checks. So another thing that I'm going to write is, do we need to do checks? If so, why? If no, why? If yes, why? If no, why? Okay, so I'm just gonna do no right now and see, because I just think from my memory that that's what was going on, but I don't know why that's the case. So root dot left, so I'm gonna do my left one first, is equal to, and now, okay, remember we need to return root. So this is a recursive function, and I'm going to return something. I'm going to return a root, and I want to capture that root here. So that's like a subroot. Okay. So I want to pass in what? I want to do self dot, what was the function called? Build tree. And I need to pass in the preorder and the inorder. So preorder of something and in order of something. Okay. So here's where the difficult part lies. So root dot right is equal to same thing, self dot, I'm just going to copy and paste that actually. Okay, like this. So now we need to figure out what is going on here. So and I purposefully moved this up so that I'm not looking at it. I want to think about it right now. And then if I can't think about it, then I look at the numbers. Like I'm not going to look at it, but wherever it is, like somewhere in here, right? So then I look at those numbers and say, hey, from this, can I determine if it should be 1 or whatever it is? But first I want to think about it and see if I can come up with just thinking. So I want to build my left. And my left one is going to be so here's my left tree. Okay, let's start with the in order. The in order is the left tree, and so I want everything, right? Everything, and then going up to index, but not including index, because index is where my actual root is. Okay, and then likewise for this one, I want to start at index plus 1, but then go all the way to the end. Now this preorder. So the preorder, I remember it was a 1, but I'm trying to think through it, you know, not just put that 1 there. So this is the preorder. The 0th element is, oh yeah, the 0th element is always going to be the root. So I don't want 0. That's why I want 1. Okay, that kind of makes sense. Okay, cool. Now, going to what? It is how many I grabbed. And how many did I grab? I grabbed this index. So I go 1 all the way to index. Or is it index plus 1? I don't know. I'm just gonna, I don't know. So it's index. And then, so I grab index is how many I grabbed, right? Like I know that it's not minus 1. But the way that I'm thinking, my brain is like, oh, it's either plus 1, index plus 0, or index minus 1. I know it's not the minus 1, but why? Why is it not that minus 1? And then I remember this one, I want to start at the like index. I think this one is plus 1 and then goes all the way to the end. Oh, it is kind of minus 1 because it's non-inclusive. So I think it's like this. I think it is like this. I'm nervous. Let's, come on. Where did I fail? All right, so I was unable to directly memorize it. I wouldn't consider that fully memorizing. I was trying to, like logic through it, but I had just seen the solution and I wasn't able to recreate it. So come back to here. I'm gonna put a little thing like, this was my failed attempt to recreate the solution. And then I'm going to submit it, put that in memory. Okay. So now I need to try to figure out, like, okay, where even what's different? What did I do that was different, and why did I have that misconception? One to index. So preorder to index here, okay? And then for the right one, I want index. Do I just want index? So it's going to be inclusive. Index. No, index is going to be 9, so I want 9 plus 1. No, index is going to be, index is here, so it's 0, 1. So now I want 0, 1 plus 1 here. So that's 1 plus index, which is what I have here, and go all the way to the end. Okay. So left is 1, 2, 1 plus index. Okay, so this is 1 plus index. In order, okay, so that's correct. Now right is 1 plus index here, and then index plus 1 there. Okay, so the only thing that I did wrong was this. I need a plus 1 here. Let me just see if that actually, oops. Like, is that my actual problem? Yes. Okay. So there's my problem, but I was logicking this out and I didn't catch that. So why does that need to be there? Do I have any more coffee left? No. I have no coffee left and no sparkling water left. Okay, so why does it need to have a +1 there? So I'm trying to build my tree, right? Okay. I'm looking at my preorder, okay? And I find my index in here, which is the 1th element. And I want to pass in the preorder, which is all of the nodes that split along that, right? Well, here. And we see in here it's just 1. So this is 0, 1, 0, 1. But it's non-inclusive. So I think this just means like get rid of that non-inclusiveness. Okay. So I mean I see it here. I see that this is the root and this is the 1th element. And then this one right here is the left and it is the 1th element, and I want to include that. Okay. So I'm going to submit that, and it should work. Okay, it works. So now what I need to do, I kind of got the memorization down. And I understand why I need to return that root, because I'm capturing something here, okay? Second question is like, okay, well, whoops. Copy that. Oh, it's, okay. In this second example, how does the program pass this case? I am not returning -1 anywhere or building a list. Okay. So this is a subtle but important point about tree building problems. How they work in Leetcode. Okay. You're asking, why does my function return a list where one element is -1 when I never explicitly returned a list of value -1? That's because your function returns a tree node object. And the platform, like Leetcode, automatically serializes the tree into a list format for display comparison. Okay. Your code does this because root value equals -1. Creates a node root equals -1. Index equals of this equals 0. Both of those return, both of these pass in, oh my gosh, both of these pass in a list of nothing and return and get back none. Okay, so none, none, and then returns a root where -1 has no children. Okay, and okay. So next steps for this problem is I worked with it just now, right? I need to think about this problem significantly more. I'm going to watch more videos on it. I'm going to think about it. I'm going to contemplate it. I need to also think about that idea of how does this whittle down my array to nothing, those nothing arrays. How does it whittle it down to nothing, and how does that base case arrive? And I need to think about all of these concepts. So I'm going to, how does this recursive function whittle down my lists until nothing is there. So an empty list. And that was one question, okay? And then I also need to, I need to think about how the placement of the Inorder, Preorder, all those different traversals. I need a lot of time to really go over and contemplate these. So I'm going to continue. I'm going to come back to it. I'm going to let this settle in my head a little bit. And tomorrow come back to it and try to once again wrestle with it. And I found that this kind of like wrestling with it and then leaving it for a day, then wrestling with it again is pretty helpful. So that's what I'm going to do. I'll be back tomorrow with this exact same problem, and we are going to continue until we understand it, not just memorize it. That's what I'm gonna do tomorrow. I'm gonna see like, okay, actually let me do that right now. Let me go and just delete all of this, right? Like there, okay? We're gonna delete it. And now when I log in tomorrow, I'm gonna see, first thing, can I redo it? Can I do it from memory? If yes, okay, well now let's try to understand it more. If no, we need to go back over it and continue to wrestle, right? So that's gonna be my method going forward tomorrow. If you're interested, subscribe and join me on this battle, and eventually we will get this problem. Like, I'm not going to stop until I understand this problem. Then we can move on to another problem within the tree section. So anyways, thank you for watching this video. I hope you have a wonderful rest of the day. My name is Timothy Lee Grant, and I will see you tomorrow. Actually, I'll see you in a few hours. I don't only do the Leetcode videos. I'm going to be making a video of more of my projects. So I do JavaScript and Java. So I'm going to be doing more videos of that today. But I will see you tomorrow for another Leetcode video. All right, bye.